Hello ladies and gentle ladies, welcome back to another stream. I know this is a very early stream compared to my usual streams, but I am going to be busy later, so I'm not going to have time to stream later, which was my original plan, so kind of throws off my plans a little bit today. But yeah, we're going to be doing another railroad stream today. And just continue with the parser. So, once again, it's going to be quite a complex stream today. So, I hope you guys are ready for that. And yeah, we'll basically go ahead and get started. So, let me switch over. There we go. And yeah, we can get started. So last time we were creating all of these different declarations and basically all of the different nodes that we want. We created the compilation unit, we created all the Java 9 ones, we created all of this AST stuff, so the AST kind, the AST node, we created the span class, we created... what else did we do? We finished off some of the Lexa, I believe, and then we also created this parser class. So we actually did quite a lot last time, in reality. So yeah, we just need to finish them off today, because obviously if we come into the AST visitor, we have well, actually from here, all of these classes to make today. So yeah, that's a lot. That's roughly like 75 classes we're gonna have to make. So commit the previous stream? No. Because there's lots of errors, like a lot of errors, and if I committed it, then everything would break. So I cannot do that, unfortunately. So hopefully by the end of this one, maybe, but I doubt it, because yeah, it's just there's a lot. But we'll see. We'll see. We're probably not even going to get through all of these today, because there's so friggin' many of them. So we might have to cut some out for now and then come back to them later. Anyways. The next thing we need to do is the field declaration. Now, I've already created the classes, so we obviously have a span, as every single one of them has a span. We have a list of modifiers, we have a list of annotations, we have a type ref, which is the type of the field, right? So if we have like int I, the type is int, pretty simple. We're gonna have a name, so a name, and then we're also going to have a list of variable declarators, which is going to be yeah, things that declare this variable, as you would suggest, as you would think. Bro is too cute to be British. What does that even mean? I don't know if that's a compliment or if that's meant to be an insult. Okay, I don't even know how to respond to that. Anyways, obviously we need to add these all as children, so we add the annotations, the type, and then we don't add the name, we add the variable declarators. There you go. Don't you have a driving lesson today? No, I do not, because my instructor is on holiday, so no driving lesson today. This is technically true, but I'm not going to do that because it would just look weird. Okay, how is the driving going? The driving is going well. My test is in 11 days, I think. And I'm really hoping I can pass it, I'm gonna be honest. Because I want to freaking just drive around, you know. But yeah, who knows? It still feels quite far away, so you know, we'll see. Anyways, is this correct? This doesn't look correct. No, this is correct, isn't it? Yeah, okay, so we can close that. We can close this. Thank you, Wyatt, thank you. I hope I do pass. I really do. I'm gonna be mad at myself if I don't, because I know the thing is, I know that if I don't pass, it's gonna be because I made a stupid mistake, and so I will be so mad at myself for it, because I know how to do everything. There isn't like things I don't know how to do. It's just like, you know, it would be a stupid mistake, I think, if I messed up. Hello Verax, welcome to the stream. Okay. That's okay, this is a mess. I don't know why it's formatted. Stop formatting like this. Oh my god, IntelliJ, bro. Okay, there we go. So what does a method have? A method has a list of annotations. So first of all, it has a span, because they all have a span. Then it has a list of annotations. Right, so a list of annotation, annotations. Then it doesn't have a name, it has a list of a modifier. So a list of modifier, which is the modifiers. Then it has the type ref, which is the return type. Then we have a name, which is the name. Also, what's with the early stream, by the way? I'm going to be busy later, so I'm not going to have time to stream later. I wanted to stream last night, but I ended up being busy last night. So, I know that I'm going to be busy later, so I'm just going to stream earlier. That's basically why. But I will probably stream again at the weekend. I don't know when exactly at the weekend, to be honest. I don't know if I'm going to stream on Saturday or Sunday. Probably not tomorrow, but I guess I could stream tomorrow in theory if I wanted to. But yeah, I don't know. Now that I think about it, in terms of structuring a method declaration, we probably want to have the type parameters before the return type, right? Because some of these could be defined by a type parameter. So type parameters are just like generics, right? So if I have like t extends list, t is a type parameter. So that needs to be before, very importantly, before the return type. Then we have the name. Then we have an optional no, we don't. Do we have anything optional? I don't think so. We have a list of parameters though, right? So a list of parameters, and then we have a... Is this correct? Yes, this is correct. So we had the thrown types, which is like if we're, you know, throws IO exception. This is a thrown type. And then we have to have a body, right? So I'm just trying to think in terms of the body, is that optional? I would say yes, the body is optional, because we could have, for example, an abstract method which wouldn't have a body. So we can have an optional of a body, which is the body. I'm just going to switch the music real quick. I was trying to download a separate thing for us to use, and it has just finished downloading. Because obviously this music that's playing right now is a little more Minecraft-y. So I'm going to go for something that's a little less like that. And hopefully it will suit the stream a little bit better. Okay, here it is. So... okay, it's kind of similar. Wait, is that correct? Has that done that correctly? Yeah, that's fine. Okay. That's good. Okay. The other thing I wanted to do was I quickly wanted to bring up my language again on GitHub so that I can see as kind of a reference what I'm doing. Got to find them all now. Okay. Okay, that's fine. One second. Let me look something up. So apparently, there's a thing in Java called a receiver parameter. According to the JLS spec, but I've never seen this before. And apparently it was introduced in Java 8. I'm trying to understand why, or why this even works. I see. Okay. It seems kind of pointless. So basically, from my understanding, what a receiver parameter is, right? Say we wanted to create a method in this class, right? So, toString, for example. Right, what we can do is we can technically, in this toString, well, we can't in this one because it overrides it, but let's assume it doesn't override it, right? What we could technically do is we could do method declaration this, and then you do like this dot annotations or whatever you do, right? Which is apparently a thing. I'm just struggling to understand, like, why? Why can you do this? There's no point. I'm trying to look at an article on it. There isn't much resources about it. So apparently, so the thing gives this example, right? This is the example it gives. So this is kind of Project Valhalla kind of stuff, right? So you're saying you have a list of ints in here if you know that this is a list of ints, but I don't know, man. That's weird. I don't know why that's a thing, but that is a thing, so I have to be able to support that, right? So what I need to have is before all the parameters, because apparently it has to be the first parameter, so you would have an optional of a receiver parameter. Yeah, look, even Java Parser actually supports that, so it is obviously a known thing. I just don't know why that's a thing. But there you go. Receiver parameter. Okay, then we need all our methods. We need kind. Oh, 1 second. We need to implement class member. Like that. Wait, do we? So these do that. I think yes, we do. Let me move this to there, and then Copilot can write the methods for us. So yeah, kind is method declaration, children. We had the annotations, we had the type parameters, not the modifiers. Then we had the return type, the name, We add the receiver parameter, we add the parameters, we add the thrown types, and then we add the body if it's present, and then that just returns a copy. So that's all of that. This is erroring at me, so let me just make sure that's the correct one, which fixes that. Obviously, we still have a bunch of errors. We could actually probably go through and fix some of these, couldn't we? Let's do that real quick. Let's quickly go ahead and fix some of these. So, we're gonna want like generic, I guess, is what I'm gonna call this. And we'll have a record, which will be a modifier. Because a modifier is pretty simple, it's just a name, right? That kind of should fix all of our modifier imports. I'm curious actually what modifier from Java Parser looks like. It just gets it as like it just has all these static methods in it. It also actually does have it as a node, which is interesting. I guess it technically is a node, but I'm not going to present it like that, I don't think. So we'll just go with that one anyways. And then we have annotations. So annotation, create a new class. Annotation, which is a record, which will have a name, and then it will have a map of string to an object, which is the values, right? Not that one. I wanted to import this one, please. It doesn't really need anything else to it. That's kind of just all it is. Okay, the next one we need is obviously names, since we've just referenced name a bunch of times. So we'll do name, which is once again a record, which will have a span. Now, since this one's an AST node, it does need to be represented as one. It needs a list of string, which is the parts, because, for example, a name could be like this, right? This is a name. So it has all of these different parts to it. So there you go. List of string parts, and then this implements AST node. Like that, and then we implement all our three methods. Return name. We don't have any children, and then we just visit name, which takes in this. So we can just do name. Name. Bro, can you please just import the correct thing? How do I make it import the correct thing? Guys, I just want to import name. Do I really? Okay, fine. I'll manually write the friggin' import. If that makes it happy. There you go. Looks like we actually do have modifiers in here as well. So that means this needs to also be an AST node. So let's implement these. Which means we need a span as well. We need the kind, so that's a modifier. It doesn't have any children, and then it just does visitor.visit modifier. Nice. We have... Yeah, we do actually have 3 different annotation classes here, so we probably should separate those out. So what we can do is refactor rename this to be... No, we don't want to rename it. We just want to change it to be an interface annotation, which will have a that's an interface, right? Yeah. Okay, so this will need to have a name, right? All annotations will have a name, and then I don't think they all need to have a list of values, right? So I think that's fine. There you go, let me just do that so as well. Hello Spino, welcome to the stream. This will do for now. And then we'll create a new class, which will be our... I already forgot what they're called. Oh, let me just fix this as well whilst I'm at it. Did we create the parameter class yet? No, we haven't done that yet. Okay. Oh, also that as well. Okay, let me just fix some of these real quick, and then we'll move on to creating these annotation classes. Okay, modifier, that's fine. We don't need that anymore. Okay, then we need a marker annotation. So marker annotation, which is a record, which implements annotation. It needs a span, and then it needs a name. Because a marker annotation is just a like normal annotation, right? That's just like at deprecated, I believe. So that's our marker annotation. We just need to obviously implement the good old methods. There you go. Doesn't have any children, and then visitor.visit marker annotation. Like that. Then we have single element annotation, so that would just be a record implement annotation. And here we have a span, a name, and then, yeah, just, I think an expression? I think. So this is saying, this is like an array. So what's a single element annotation? Oh, that's like doing like, like if I want to do app deprecated like this, right? No. What's one that does this? Why can I not think of one that does a single element annotation? Guys, what's an annotation that has a value in it? Like just one value. Can anyone think of one? Nullable, I don't think does. I don't think any of these do. Okay, well you guys know what I mean. Oh, suppress warnings. Suppress warnings. You can just like suppress unchecked, right? So this will be a single element annotation because that's all it is. It's just a single element. But if it was like this, so we were saying unchecked raw types, that would be a normal annotation. I think. No, this is a single element annotation. Right? A normal annotation, I think, is saying like value is equal unchecked. And then you can say like, no, it's just like this, isn't it? And then you can also say, you know, like that. Is that how you do it? Something like that. That's obviously not an actual thing. But for example, in like a deprecation annotation, you can do that, can't you? So you can, yeah, you can say since and for removal. So I can say since is equal blah, for removal true. That would be a normal annotation, I think. Maybe? Oh, so can that also be an array then? No. If you have a string array, then sometimes you can put a single string. Yeah, but how... normal annotation. You know, let's go to implementations of annotation. Single member annotation. So this would be like type name expression. So that's foo bar, right? So then what's a normal annotation? Type name an array? Or an array of... array is with... oh, of course it is. I'm an idiot. I got confused because in here it shows it as being the square ones. But yeah, you're right. It would be like this, right? It doesn't like that though. So I don't know how you actually like... a single element, or what was it? Single member is just saying... oh, no, it's saying that this is a normal annotation. It's saying that this is a single member. Right? So it does just have... this one just has an expression. That's all this is. And then... the marker annotation. So let's look at the marker annotation. We'll go this one. That's just at type name, right? So that's all that is, nothing else. So then a normal annotation I don't really understand normal annotation. Is a normal annotation just saying like this? Is that all it's saying? Is this a normal annotation? I think that's what it means. So, like, this would be a normal annotation. Suppress warnings unchecked. That would be a single element annotation. And then at override would be a marker annotation. So marker, single element, normal. I think that's basically what you're saying. Or what it's saying. I got it. So marker annotation we've already got is correct, because that just has a name and a span. That's it. Single element is correct because that's just a span, a name, and an expression. So that's not the ones it wants. It wants kind, which is single member annotation, which, yeah, that's actually not correct. It should be called a single member annotation. Then it wants children. I don't know if it has children. I'm gonna be honest. Single member annotation. This one. I would say probably. I would say this is probably correct. And to be honest, actually, if we're being real, these should all have children. And it should be a matter of marker annotations child being the name. One second, let's close some things. Then the single one will have those. Let's quickly do accept visit single element annotation, which I'm quickly just going to rename to a single member annotation. And then the normal one, new class, which will be a record. So this will have a span, a name, and then a map of name to expression, which we can probably have a little node for, right? So that can just be sure, yeah, whatever. Okay, why is it complaining? Because it must implement children. Name elements. Yeah, you can't do that. Ow! List of AST node like that. I don't want to do that, of course, because that's not gonna work. Array list like that, and then we can do children, but add name. And then for each of these, that's always going to be true. I don't know why. Add elements. There you go. This is in the JDK. That's fine, because we're not going to actually use that. This needs to be list.copy of children, because otherwise that will be modifiable, which we do not want. So then this is just a normal annotation. Let's quickly do these ones as well. Yeah, so this doesn't have any children, because the parts are just strings, so that's fine. So the next one is parameter. Let me look how to define a parameter. So generic. Oh, I don't know why I'm yawning so much. It's the middle of the friggin' day. Okay, record. So this implements an AST node, which I guess I did like that. Yeah, here you go. Okay, then we have a span. We have a list of modifier, because obviously parameters could be like final. They could be... Is that it? Parameters can only be final, right? I don't think you can define a parameter as anything other than final. You obviously can't do like private. That doesn't make sense. Is there anything else you can do to a parameter other than final? Can you do like transient? I don't really know what like transient means, so I don't know. I'm not sure, but I know it can have a list of modifiers anyways. Then we have a list of annotation, which will be the annotations. Then we'll have a type ref, which is a type. Then we have a boolean. Is varargs, right? So that's for doing like a ... You know, A's. That's varargs, and then we have a name, right? So we have a name. So we have kind, which is just a parameter. We have children, which is just name and yeah, just type a name in that order, ideally, though. What's good, gang? What's happening? Right now we are doing the same thing we're going to be doing the rest of the stream, right? We're going to be writing out all of these different classes. Okay, I kind of want to make... Yeah, so we need to make type parameter. Oh, God. And we need to make receiver parameter as well. Okay, let's do type parameter. So let me split this up a little bit. So we'll do annotation. I think I can call that annotation. I hope that's fine. Refactor. And then we have a new package. GUI parameter. Honestly, I should just move these out of this generic class. I don't really know. There's no point having anything else. Parameter, there you go. Move into there. Okay, then we have our type parameter. So type parameter, which is going to be pretty similar, kind of. So it'll have a span, of course, as you can probably guess. It will have a name. Actually, it won't have a name. It will just be a string name, because you can't do... like, you can't have like t.t name, right? Because type parameters don't let you do that. So it's just a string. It's not a node or anything. Then we have a list of annotations, because they can be annotated. And then we have a list of type ref, which is the bounds. So that's like saying, for example, t and you know, h or something would be the bounds. This isn't actually going to implement parameter, because it's not really a parameter. It's just going to implement AST node. Then we want the kind, so that'll be type parameter. We want the children, which will be type and receiver name. So type. No, sorry, that's the... No, what will this be? This will just be the bounds, right? Because you... No, it'll be the annotations and the bounds. So it'll be... We want a list of AST node. Children is equal to... Nope, let's do... New array list. Then we add the... annotations. Then we add the bounds, and then we return a list copy of children. Okay, we need to create this typeref class soon, because we're using it a lot. And then we want the accept method, like that. Okay, and then we want our receiver parameter as well. So let's close that, let's close that, and that. So we want a new class. This is going to be a record. It's going to implement AST node. Oh, oh my god, AST node. once again, span. This one is going to have a list of modifiers again. So modifiers, because maybe you wanted to define it as final or something. It will have a list of annotations. Annotations, yeah, that was correct. Then we have a type ref, which is the type. And then it can be the name, so name. Which will actually always just be this, right? Or can you also, like, define the super? Like, could I do, I don't know how you would even do that, but... Oh, God. I'm yawning way too much, man. Like, could I do public void my method? AST node super? No. So isn't it always just this? Or can I do like receiver? Like if I do receiver parameter this, but can I do receiver parameter super? No. So isn't this always just this? Or am I crazy? I could be crazy, guys. Let me have a look, actually. JLS spec, receiver parameter. Trying to see if it at all mentions. Oh god, this is receiver parameter. Yeah, so it's always this. I think you can also have oh, right. So there's also like... Okay, 1 second. This is very confusing. Yeah, so you have the receiver parameter. So this is the spec, by the way, guys. So it's basically saying you have a receiver parameter, which if you look at that is the annotation, then it's the type, and then it's an identifier. Can you not have modifiers? 1 second. If I say this, can I not do final? You can't. So it actually can't have modifiers then. So it can be annotated, so I can say not null, right? Don't know why you would ever do that, but you can do that. But you can't do final for whatever reason. I don't know why. But sure. I guess it just implicitly is final. So... Actually, let me bring that back. I'm going to keep the spec up on my other monitor as well. So there isn't really any point in having a name. I will keep the type because it technically has a type. even though the type will always be the class it's in, it's useful if you have a receiver parameter to be able to get the type from it. So it makes sense to have a type inside of it, as technically it is a child of the parameter. So that's fine. Now we don't actually have that in here because ChatGPT never told me to add it. But we do need it. So let's find our parameters. Type parameter, here we go. And then we want a receiver parameter. This says it's a Java 9 standard, but everything I can find online says it's in Java 8. Java receiver. When were Java receiver parameters added? I'm going to search this on Brave because Brave will give me the AI result, which will probably give me a more accurate answer. Okay, yeah, it is Java 8, so Java 8. Okay, perfect. So that's the kind. Then we have the children, which is just the type, or just the annotations, and then the type. So list of AST node children is equal a new array list. Okay, and then we do add annotations, add type, and then return children. List.copy of children. I think I've messed that up somewhere. At some point I haven't done that, and that'll bite me in the butt in the future, so I'll need to go back through all of these at some point, but we can worry about that when we get to it. So visit receiver parameter. Yeah, we need that. We don't have that, so visit receiver parameter. There you go. And what we can always do afterwards is we can compare everything we have to like Java Parser. We can look through all the classes they have and compare, but we don't need to worry about that right this second. Okay, let's create this typeref class that we're referencing all the time. So let's create a generic class typeref, which will be a record. So there are multiple different typerefs. It's actually not going to be a record because there are multiple types, and this will be sealed for that matter. That's not how you do sealed, is it? You put it there. Okay. This extends AST node, and then we have all of the ones it will permit. So we're going to permit a primitive type ref. We're going to have an array type ref, and then class type ref, type variable ref, yes, and then it's got wildcard as well. I think that's technically what we want, yes. And these will all have a name, right? So, but the name will just be a string. So it will just be string. Well, I guess it might not always be a string though. So actually, let's not have that. Let's also not have this primitive one. That's stupid. That doesn't make sense. So we're not actually going to have anything in here. But that's fine. Okay, let's create a new package for typeref. And then create a new class, primitive typeref, which is a record. We have a span, and we have a string keyword. which implements type ref. Like that. Implement our three methods as usual. We have primitive type ref, right? We have primitive type? I guess that is actually probably the one we want. Then we have the children, which it doesn't have any children. It's just a string. Nothing special. And then visits primitive type, which will reference our primitive type ref. Array type ref. Class type ref. Type variable ref. We also have intersection types and union types as well. Union type ref. Wildcard type ref. Well, we technically don't need the refs, but I think that just makes more sense in my head, so. Actually, does it? I'm kind of 50-50 on it, actually. I think it's just that having like a class called class type or array type is a little bit confusing compared to having like array type ref, which clearly references the type of an array compared to what this would be otherwise. So I think this just makes more sense in my head to do that. So let's quickly go into here and permit the other ones. So intersection type ref. We have the other one, which is a union type ref, and then we have a wild card type ref as well. Oh, we do not want these ones though. Let's do this so that they're kind of separated like that. That just permits all our classes. There we go. Have you done many fun things today? No, Wide, I have not. I haven't done anything today. And I say anything, I mean literally anything. I just been watching YouTube shorts. That's all I've done today. I've been so unproductive. There was things I needed to do today, and I just haven't got around to doing them. I'll have to do them later instead, which is going to be a pain in the butt, but it is what it is. So array type ref. So this is going to have a span, of course, so span. Then it's going to have the type ref, which is the type of the actual array, right? So, or type of the elements in the array, really. So I would prefer to call it like element type. And then we just have a like a because an array type doesn't have to be a singular dimensional array, right? Like you could have like T array. That wouldn't be two array type refs. It's still one reference, but it's to two arrays. So I have to know how many what's the word I'm looking for? Dimensions. That's it. I have to know how many dimensions the array is, so that this can represent multiple dimensions, basically. So that would be an array type, like that. visit array type, which would be array type ref. There we go. And it's complaining because they haven't done children, so the only child is the element type. That's it. Then we have the class type. Oh my god, I actually don't know why I'm yawning so much today. I slept quite a lot last night as well. Okay, let's close all of these. Make sure they're all closed. This needs to be that. This is complaining because of that. We'll come back to that. I think I'm probably just going to leave it as it is. Okay, class type ref. So this is going to be very similar, I believe. The only difference is that this one will actually like have a name, right? So we're saying span, then we have a name, and then we have a list of type ref, which is the type arguments. So then this is a class type, or class or interface type, sure. So we'll do class or interface type ref, like that. Hello Diablo Extreme, welcome to the stream. Okay, so we want our list of our AST node. Children is equal to a new array list. There we go. Last time I saw one of the stream you were working on Alexa or something. Has that been finished? Yes, the Alexa has been finished, albeit not tested. So whether it actually works or not is a mystery. I need to write tests for it, to be honest. I probably should have done that before start. Well, I guess not really, because they're kind of independent, right? This is me doing this right now is independent of whether the tests will pass or not. But yeah, I probably should write tests for the Alexa, but it is done in terms of like feature complete. Let's rename this one. What interface type? So yeah, now we're just working on the parser, or really the AST right now. We haven't actually got to the parser itself yet. We've wrote the generic kind of template parser class, but we haven't wrote the parser itself. So that's the next step after this, but this is going to take a while anyway. So what problem is this IDE trying to solve? This I don't know that there's necessarily a problem that we're trying to solve per se, because I mean there are, but maybe I guess some problems you could call them, which are really just, you know, you problems to whoever's having the problem. But yeah, we're not really trying to solve a problem. We're trying to ease the experience, really, and improve the experience rather than solve a problem. So, for example, one of the things I always like to kind of reference when it comes to like what the IDE is actually gonna do. I mean, really, we're just gonna have a lot of things built in, right? That's kind of the idea. Oh, I've got something in my eye. But yeah, the idea is we're just going to have a lot of things built in, right? So we're going to have, for example, things like a model editor, things like a texture editor, possibly audio editors. I'm not sure if we're going to do that because that's very complex. Audio is a pain in the butt, but maybe like an audio editor, at the very least a visualizer. Things like a built-in structure editor, built-in like NBT viewers, right? So you could literally just open an NBT file and you would view it as the actual different like NBT things. What's that program that does that? NBT viewer. What's it called? There's actually a lot, but there's one I'm thinking of specifically that everyone knows. I don't know. I can't find it. That kind of thing, right? And then we're going to have things like a lot of Minecraft-specific inspections. Think, for example, maybe you're writing... Okay, this is a problem I've had recently, actually, and this is something I do want the IDE to be able to handle. So, say, for example, you're registering an item, right? So, say, for example, I'm doing our usual thing. So, public static final, item... Let's say we're registering beans on toast, right? And then you do equals register beans on toast, right? You'll see here I accidentally spelled beans wrong. Now, to be fair, IntelliJ is telling me I spelled beans wrong. But say I accidentally put... I don't know how I would mess this up, but say I put toast on beans, right? It's not going to tell me that's wrong, right? And it's not going to tell me that these two are not different. So a thing that Railroad might do is it might say, hey, this is different to this. This might not be what you expected, kind of thing. Right? Just as like a small example, that's one of the many different things it could do. It also, one of the big things that I want to do with Railroad is I want proper built-in like mixin support. So if you guys have ever used the Minecraft development plugin for IntelliJ, it kind of has support for mix-ins, but it's not as far as I want it to be. So something, for example, like... I don't know how many of you will know how mix-ins work, so I might just be talking to a brick wall. But basically, right, they inject into the code. So I would say inject, and I would say the method, or you would say, well, first of all, you would have the at mixin, right, which goes into whatever class you're doing. So I don't know, armor item dot class, right? This would be your armor item mixin. Okay, this is a quick mixin tutorial for you guys, I guess. Accidentally in a Railroad stream, but here we go. So then you would write an inject method, right? So you'd inject into whatever method you want to add code to. So sure, we'll go with whatever Copilot said. So we're going to inject in the get armor material method. We're going to inject at the head of the method, so at the very top, right? This could be cancelable so that we can maybe do a return statement or something. And then we would have our private void, you know, tutorial mod $get armor material, which would take in whatever parameters this has. So I don't know what parameters this method actually has, but let's say it has a item stack or something, right? So something like this, right? And then it would have a callback info. So this is basically how a mix-in would look, right? This isn't going to be valid code, so don't try this. But you would have something like this. So what this would do is it would go into the get armor method, right, inside the Minecraft code, and it would add this in there, right? So it would add if stack.getItem is instance of this is a dumb example, but whatever. It would add this, and then if that's true, it would return this value. Else it would return this value. That's also a dumb thing to do, because it should probably just do what the method does. But, you know, you get the point, right? But if I go into the armor item class, I obviously can't do that, but it won't show you that inside of this get armor material, because it happens at runtime. So something that Railroad would do is when you go into the armor item class, if you have a mix-in that goes into that class, it would show you that there is code injected there, right? So it would obviously scan your whole project, and it would say, hey, there's mix-ins in this class, mix-ins in this class, in this class. They're here, here, here. This is what they would do, right? That kind of thing. That's obviously a little bit niche, because obviously not everyone is gonna be using mix-ins, right? But it's that kind of thing, really. It'll just have a ton of features in one place, like text editor, screen GUI editor, model viewer, a ton of helpful features. Yeah, basically that. So it'll just be a bunch of helpful features. Could a potential feature having it oh god, hot load code? It already does that. Well, IntelliJ already does that. I mean, like, that's not that won't be anything special. But yes, it will have that. But I mean, every IDE has that, so I'm not sure an IDE would be very good if it didn't let you do that. I mean, that's not even really handled by the IDE. That's handled by the JVM, right? So, you know, I edit the code. I say, you know, int a equals 5. And then I have to build it, right? Which is just a Java thing. You're just compiling the project. And then the JVM says, like, hey, I see this class has changed. I see this method has changed. I see this has been added. Is that something I can add? Yes. So let's add it, right? That's all it does. It's not, you know. I also really shouldn't have built, because I'm going to have so many errors and it's going to lag IntelliJ so much. But you can only hotload certain code, right? Yes. So if I wanted to add, for example, public, oh god, yeah, I really shouldn't have done that. Alright. If I wanted to add like this, I couldn't do that with hot loading or hot reloading. But if you use a certain JVM? No. What's the thing you use? 1 second. I'm gonna try and find it. DC EVM, that's what I'm thinking of. If you use like DC EVM, or I think IntelliJ has a certain JVM or something that lets you do it. But if you use one of those, then you can hot swap methods, you can hot swap classes, those kind of things as well. But yeah, I mean, that would just be handled by whatever JDK you're using. Yeah, well, JRE in reality, but that's besides the point. Is this correct, by the way? Union types, they're just a span and a left and a right, I think. Yes, I think so. But yeah, anyways, hot swapping is going to be an essential. It will be something that's added. It's just a matter of building the project and hot swapping it, right? That's it. And I want to have like built-in support for single hot swap, so that just hot swaps whatever file you have currently active. IntelliJ, you need a friggin' plugin to do that. But yeah, there's no reason why we shouldn't just be able to build that into the IDE, because that saves so much time when you can do that. But yeah, that's definitely one of the things. There's no shadow of a doubt about that. What's this? I'm trying to think about a wildcard type. Let me have a look at the wildcard. I'm trying to see. Okay. So wildcard. So a wildcard is well, really this is the wildcard bound. So I'm saying you have a you could actually have multiple, right? So you could have, let me have a look at like this actually. Yeah, so that's fine. This has like type arguments, which is kind of what I want. But in reality, you would have a span as kind of usual. Let me have a look at this one again real quick. Then you would have a name, which would actually just be a string, so a string name. No, you don't have a name because it's wildcard. It's like this extends, you know, string, right? So it doesn't have a name. Then it has a extends bound, so an optional of type ref extends bound, and then an optional of type ref super bound as well, because you can, for example, say like question mark super some class, right? Or you can say extends some class. I don't know if you can do multiple. Like, can you do extends and super? I don't think so. So actually, I guess what it had before is probably correct, right? So a type ref bound, and then boolean is super bound. But then you wouldn't necessarily have this, right? There isn't. It could be neither, because I can just say like I can do that, right? Obviously not in this case, but so in that case, I could have an indeterminate boolean, or I could have a boolean like that, which means it could be null. Which is basically a tri-boolean, right? Which isn't actually a thing, of course, but effectively, I think that will be fine. So bound.map list.of, or else get list.of supplier of a collections.empty list. Why is it complaining about that? Require type list of AST node provided a list of type ref. What's wrong with that? What's wrong with that? This is an AST node. Am I being stupid, guys? Required type list of AST node provided list of type ref. But a type ref is an AST node. Is it because of it being streamed? So is it because of type erasure? There must be type erasure. I reckon that's what's happening. So I think if I did like this, right, and then I did bound.ifPresent, children add, and then return a list .copy of children, that works, yeah. So it was because of type erasure, because optional holds the type ref, and then that was being held inside of a list, which was then being streamed. So it turned into a list of... Wait, no, it would have turned into a list... No, a stream of a list of... A stream of a list of question mark, I'm guessing, which is why it didn't think that question mark extended type ref. No, AST node. Because it doesn't know what question mark is. I think that's what happened. Dank Java moment, I guess. It probably would have compiled if it wasn't for that, but it is what it is. What's next? I think that's everything in terms of like the generic stuff. Let me just quickly have a look at my code here. We probably do want a block statement. Do we have a block statement in here somewhere? Yeah, we have it here, which is just a list of statements and then a variable scope. Okay. We'll do that when we get to it, actually. We'll just go in order for now. So have we done method declaration? Yes, we have. Let's do some imports for everything then. So type ref, that's gonna be a pain in the butt, isn't it? There you go. And then we have parameters like that, and then we have a body. We haven't got to a body yet. I think a body is actually a body declaration, isn't it? No, we haven't actually got around to body yet. But that would just be a block thing anyways. Class member is something we should really have. Let's try and create that real quick. See if I can find where I've already defined that. What are we looking for? Class member. I don't think a class member is anything special, right? In reality, it's just an interface, I think. Like, it's not actually a thing, it's just an interface, and it's just saying, like, if you wanted to do, like, hey, is this thing an instance of a class member, then you would just check if it has this interface. Yeah, it doesn't actually, like, do anything. Although this wants it to extend AST node. I guess it could. Sure. Extend AST node. There you go. Receive parameters.ifPresent children.add. Oh, that's because that's from the wrong place. So we want 1. And now the only one that's complaining is the body. I'm trying to see if I have a body lying around. Don't take that out of context, please. God, I have so many freaking things. Okay. We'll come back to body, because that's going to be a later on thing. We'll do constructor declaration, which just if I have that one. Yes, I do. So that's going to be nice and easy to do that. So we're going to class. We'll create a new class. Let's go make a record. So this will, most importantly, have a span. So a span. Then you'll have a list of modifier, which is the modifiers. Then you'll have a list of annotation, which is the annotations. Then it will have a list of type parameter, this one, which is the type parameters, aka the generics, right? Then we have a name, which is the name. Then we have a list of parameter, which is the parameters. Then we have a list of type ref, which is the thrown types, sure. And then we have an optional of a body, because obviously constructors, well, constructors technically do need bodies, right? Also, I am just going to make this a block statement, I think. Because that's all it is. It is just a block statement. There's no reason for it to ever be anything different. So that's fine. Does this have the throne? Yes, it does. Okay. I wasn't sure if it did or not, but yes, it does. Okay, so that has the body like that. Let's import list, so this can stop complaining. Let's import name, so that can stop complaining. And import that as well. Okay, this needs to implement class member. And then we can have kind, which returns constructor declaration. We can have the children, which has a list of AST node children equal to a new array list. Okay. So what do we want? We want the annotations. Modifiers aren't an AST node, are they? They are. Okay, those should really be added then. Then we have the annotations. Then we have the type parameters. Then we have the name. Then we have the parameters. Then we have the thrown types. And then we have the body if it's present. And then we make a copy of that. Now this is complaining because we don't have our accept method, so we'll just return visit constructor declaration. Boom. Then we have a compact constructor declaration, which is going to be kind of similar, but it's going to be much simpler. So we're going to have our span. We're going to have a list of modifier, which is the modifiers. We're going to have a list of annotations, which is the annotation. And then we're going to have... technically, it does have a name. Sure. And then we have the optional of a block statement, we'll go with that one for now because I can't be bothered to have it complain about me. Now, question. Can compact constructors throw things? I don't know. Compact constructor declaration throws runtime exception. No, they cannot. Okay, sure. That's fine then. So then we have to implement class member. Technically this is only a record member, but I don't know if we should maybe clarify that in the future. Not sure. Kind is compact constructor. Children. This is just a new array list for now. Add all modifiers, add all annotations, add name, and then add the body if it's present. And then finally, accept, which returns that. Nice. Then we have enum. Which hopefully shouldn't be too bad. So we're going to have a new, not a Groovy class, no, just a Java class. And I think all this needs to have, because enums aren't that complicated, really. They can't have much, right? So it's really just a span, and then I guess it can have annotations, right? Can enums be annotated? Public enum my enum. What can I annotate this with? At deprecated? Yes, so they can have annotations. Oh wait, am I being an idiot? Yes, I'm being an idiot. This is an enum. We're not talking about, like, we're talking about an enum as in an actual constant, right? This is an actual constant in an enum. So we're saying like A, B, C, like these are enum constants. So I'm actually being a little bit of an idiot. So we'll have a span, and then we have a couple things. So we have a list of annotation, which is the annotations, and then we have a name. Now, question. Enums can have a body, can't they? Like enum constants, I think, can have a body. Because you can do like, first of all, let me import this real quick. Actually, I want to go to this one. Just to have a look. Yes, they can. They can have a body. Because if the enum doesn't implement methods, right? Okay, first of all, let me fix this back to what it should actually be, which is that one. Close that. So you can do public enum my enum with a body, and then you can do like a, is it just like this? Yeah, you can, which is super weird, but you can basically have it override whatever methods are in here, right? So I think you can also have fields. Yeah, you can. Can you have like... You can. So this is like a full class body. That's kind of crazy. I actually didn't know that. I knew you could override methods in here, but I didn't know you could... Can I do this? You can have classes inside of an enum constant. That's crazy. Because I can't like do... You can't do my enum constant with a body dot constant one dot test class, right? Where am I doing this? Test class. No. Because you can't access that. But you can't do that like this either. So technically this class is completely just like non-existent, I guess. It's kind of crazy, actually. I don't know why you would ever do this, by the way, but it is a thing you can do. I don't know why you wouldn't just have like a lambda in the constructor or something, for whatever you wanted, but sure. So we actually want a body then, right? So we can have a... I guess we can just have a block statement, right? Class body. Or no. No. It's not really a block statement. It's like a list of class member body. Because it's not... Yeah, it's slightly different. Hey, what theme are you using? I am currently using IU Dark. AYU and then Dark. And you can find that in your IntelliJ plugins, or any just JetBrains IDE has it, so. What the hell is this? Let's just not do that, please. Yeah, I don't know why Copilot tried to do that. So annotations, name, body. Nice. You can't have any modifiers, right? Don't think so. Okay, so let's make this. Yeah, that's fine for now. We can come back to those because those are slightly different. They're not quite the same. Okay. Then we have an annotation type member declaration, which is a little bit more complicated. Still pretty simple. I mean, all of these are relatively similar, right? So they all have a span. This one is going to have a list of modifier, which is the modifiers. Then it's going to have a list of annotation, which is the annotations. It's not going to have like a... It's not going to have like type parameters or anything, because annotations can't be typed. But it will have apparently a type reference. But I don't really know how that's the case. Let me have a look to see if I can find it. Let's see, annotation type declaration. So it has a modifier, so list of modifiers. It has... Wait, can annotations even be annotated? I think they can, right? So I can do at deprecated public at interface my annotation. Yes, so they can have annotations. Okay. So it'll be list of modifiers, list of annotations, and then we just have a name. And then we have a why does it want a type preference? Am I missing something, guys? Why does Copilot think I need a type preference? Oh, because this is an annotation type member declaration. We're referring to a member of the annotation. So like one of these, right? This is what it's saying, that it has one of these. So I'm looking at the wrong thing. So yes, we do want a list of modifiers. Can this not have annotations? No, they can. They can have annotations. I thought so. I don't see why they wouldn't have been able to. Right? Right. So we have a list of annotations. We have it can be many things. So you have modifiers, you have annotations, then you have a type, right, which is basically saying this type. So we have a type ref, then we have the name, which is the name of the method, basically. Then we have dims, apparently, which is what? I'm trying to have a look at what this means. So this is what it's saying a dims is, guys. Or just this, I guess. So dims is an annotation array. And then what? I'm confused. What does dims mean in the JLS? In the Java language specification. Let's 1 sec. Let me Brave search this so that I can get an AI response, which it didn't want to do. Okay, here we go. So term dims does not have a specific defined meaning within the core specification. However, in context of the dimensionality of arrays or tensors. So it's just the dimensions of what, though? So the thing I'm looking at, by the way, guys, is this. I don't think I need that, because I think... So is it saying that I could have, like... I don't even know what it means, I'm gonna be honest. It, like, does it mean like this? Oh, no, it means like this. Wait, what? What does this mean? That refers to the string? Wait, this is saying it's a string array? No. Is that actually what it means? Oh my god, it is. Why can you do that? That's horrible. That's so bad. Oh my god, okay. I'm just gonna ignore that. And I'm just gonna say that has to be part of the type ref. However this is defined, that will have to be part of the type ref, because that's stupid. That's so dumb. You should not be able to do that. Okay, then it has a default value, which I think is just an expression, right? Is that correct? Default value is an element value, which is an expression, an array initializer, or an annotation? This can be an annotation? What does that even mean? Does it mean, like, if I made this return annotation, then this would be... No, I have no idea what this means. I don't see how it could be an annotation, I'm gonna be honest, guys. Yeah, expression just makes sense, that's fine. List, and then a modifier becomes that. This needs to implement a class member, I guess, because it is a class member. Let me quickly move my windows back in. Yeah, so this is just a class member, so we can implement the methods like that. This will be a list of AST node children is equal to a new array list. Adds the modifiers, adds the annotations, adds the type ref, adds the name, and then does it need a default value, or is that optional? I think that means... I think it's optional. One second, let me look at the notation. Yes, it's optional, so that means this needs to be an optional. Oh, like that. There we go. So if present, add that. We don't have an expression yet, so we'll come back to that one. We need to fix that. There we go. Okay. Oh man, this is going to take a long time. I don't know why I did that. I need to keep my mic facing this way. Okay. Next. We're going to be here a long time, guys. I'm going to be honest. So, the static initializer block is effectively just a block statement. So I'm going to create a new package, and I'm going to call this statement. Do I want to create statements, or do I just want? Yeah, let's go statements, and then let's create a new. That needs to go inside impl. Okay, and then inside of here, I'm going to create a new package for block, which will contain our block statement. Or we can do a statement first. So statement, which is an interface which extends AST node like that. And then this doesn't actually do anything, right? So it wants that, but we don't need to do that because those already exist. So we just need to move this. So refactor, move class to statements. Okay. And then we can have our static initializer block, which implements block statement. Not block statement. No, it does implement block statement. Yes, it does implement block statement. Okay. I'm getting confused now. Because it takes... No, it doesn't. It doesn't. Oh my god. It implements a class member. Or... Yes, it implements a class member. And then it takes in a block statement. Like that. Which is the body. Right? And then that has the kind. And then we do the children. Which is just a list of body. Nothing exciting, unfortunately. And then this needs to be that. That's fine. Then we have instance initializer block, which you probably guessed it, is actually identical. The only difference is that this will be an instance initializer block, and this will visit instance initializer block, like that. Then we can do our block statement. Also, why is this complaining? Oh, it needs a span. Of course it needs a span. Oh my god. Span. Oh my god. Span. Okay, there you go. Same with this one. Span. Okay. Let's create a new class, block statement, which will be a record, which will implement statement, and this will just have a list of statements, which is the statements, and it obviously, you guessed it, has a span as well. Okay. Implement our methods. So return block statement. Return list.copy of statements, and then return visit block statements. Okay, what I'm going to do is I'm going to find this. Okay, and I'm going to find what to replace that with, which is this one. So I'm gonna replace with import block statement. Okay, and then do, yeah, project files, replace all, replace. Okay, which should just fix a bunch of errors for us. Let me quickly also do a optimize imports. So that just fix some of the imports which don't need to be there. Yeah, we'll come back to this because we haven't done expressions yet, so that's fine. Yeah, that's all of those. Then we have empty statement, which is as simple as it goes. I'm gonna be honest, guys. This is the simplest class we're gonna write today. Implements statement, override kind, which is empty statement, override children, which is just an empty list, and then override accept, which is just visit empty statement. Nice and simple. Labeled statement is going to be pretty similar to the block statement. Oh, an empty statement does actually need a span though, doesn't it? Technically. It will never actually have a span. Like, the span will always just probably be 0 for everything, but it technically does need one. But yeah, okay. So next is labeled statements, which is going to be super easy as well. So that will just be, I'm trying to think if it's a name or a string. I think it's probably just a string. So it'll have a string. Oh, first of all, it has a span, of course, span. Then it has a string label, and then it has a statement. Right now, does a statement have to be a block or not? No, because it could be like a while statement or a yeah, or a for loop or something. So this is just a statement which implements statement like that. Let's implement our good old methods. I accidentally bookmarked that again. I need to remove the bookmark key because it's annoying. This just returns the statement, and this returns visit labeled statement. Here's what this one is. Yeah, this just has a label and a body. Nothing special really going on there. Expression statement is as simple as it goes as well. This is just a span, and then an expression implements statement, override our methods, expression statement, list of expression, visit expression statement. Change that to that. Then we have a local variable declaration statement. Now we're getting back to the complex stuff. So, well, I say complex stuff, this isn't super complex either, but we have obviously our span. We have the list of modifiers, which is the modifiers. There you go. Import list. Then we have a list of annotations, because local variables can be annotated. Then we have the type, right? So the type ref, which is the type. Then we have we need to know if it's a var. So boolean is var. Then we have a name, right? I think. Or no, I guess we have a list, right? We have a list of of variable declarations, because you can do, for example, like you can do like int a equals 5, b equals 4, c equals 6, right? Obviously, if it was in a method, so like that. So technically, these are the variable declarations. So, and then this is like the type, right? So this could be final, this could be deprecated, and that would apply to all of these. So we want a list of variable declarations. So a list of variable declarations, like that. Or local variable declaration. I guess it doesn't really matter, but it's just a variable declaration. It's not anything exciting. So variable declaration statement. This needs to be a list of AST node children is equal to a new array list. Add the modifiers, the annotations, the type, and then the declarations. This is not null, whatever. Sure, that's fine. Let's create the variable declaration real quick. And actually, I realized that these are not block statements, are they? So this, this, and this are not block statements. There we go. And then I guess variable declaration is just generic-ish. Like, it's pretty generic, right? Now let me see where I have that, because I do have it somewhere. Okay, found it. So we have a span, because obviously it's going to be a node like everything else. We have a name, which is the name of the variable. And then all we have is an expression, right, which is the value. So expression, which implements, what does this implement? I guess just AST node, right? Or is it even a node? Is it technically a node? I would say it's a node. I think that's reasonable to say that this is a node. Only problem is I don't actually have a variable declarator. Oh no, I do. Variable declarator. So I should probably rename this then to variable declarator. And then this is just a list of name and expression. Now, expression is optional, right? Init expression, we'll call this. But that's optional because I could do int a like that, and I could even do int ab like that, which means there's no init expression. So this is actually optional of expression, which means that I have to do a list of AST node children. Would you consider yourself a genius programmer? No, definitely not. I'm very far from that. Don't get me wrong. I know I'm not bad at programming by any means, but I wouldn't say I'm a genius programmer. There are people which are much better than I am, like orders of magnitude better than I am. So no, I would not say that's the case. Let's create a package for declarators because we're going to need a couple of them in the future. Let's also create a package for expressions because we're going to want a bunch of those. I'm thinking in terms of this semantic syntax tree stuff, we might want to extract it out into its own library, right? So it's a completely separate library from Railroad. Just because, I mean, you can already see that these packages and these imports are getting very long. And we could kind of, I mean, we actually couldn't cut much out. We basically cut out the IDE package in reality, and the SST package as well, I guess. So that's getting rid of these two, but I think it would be nice to have it as a separate thing anyways. In fact, this is going to need to be in Railroad Core. I probably should have started writing this in Railroad Core, now that I think about it. But as a completely separate library is actually would make more sense. I don't know why I didn't think of that originally. What's your thoughts on vibe coding? I think it depends. I think it depends what you're using it for, to be honest. I think you can very easily... One second, let me just read the declarator. I think it's useful, but I think it can be misused. I think most people vibe coding probably misuse it. I've done my fair share of trying to vibe code to see what it's like, and honestly, I've hated it every single time. The problem with it, the biggest problem with vibe coding, is you find yourself not being able to actually do what you want, right? Like you will ask it to do something that you want it to do, right? Say, for example, I want it to create this if statement class. It may create this if statement class, and it may have most of what I want in it, but it may miss something. But because it didn't add that thing, I might not even think about adding that thing. I might not even think, you know, oh, this is right. I may just not question it and move on, right? And then you'll find that just bites you in the butt later. Like, massively bites you in the butt. So that's one problem, but it has loads of problems, right? I mean, overarchingly, it's basically just cheating. Like, you're not actually building anything of worth, right? If an AI could write it, in reality, it's not worth writing, right? It's just not. Because if AI can do it, it's just not worth writing. Just forget it. I mean, that's the same with most jobs, right? Most jobs that are going to be replaced by AI, in reality, are going to be jobs that, like, no one really cares that they're replaced by AI. Not for all of them, but for most of them. Like, consider, for example, what's a good example here? Okay, like, for example, I don't think a teacher could be replaced by AI, even though AI could teach. I think the fact is, to teach, you need human interaction, right? If you're just learning from a machine, you're not going to have human interaction, so naturally, your learning skills would just deteriorate, or they just wouldn't exist in the first place, right? In programming, I think the good use for AI is basically what I'm using it for: autocomplete, right? Use it as autocomplete. If you're using it for anything more than autocomplete, you're using it wrong, is what I would say. To teach, you also need to have accurate information. Yeah, I mean, currently AI has a pretty big problem with hallucinations, and I think in reality it always will, because AI isn't able to actually go out there and like think, right? I know AI has all these, you know, quote unquote thinking modes, but it can't teach itself things, which in order to teach, you need to be able to teach yourself things. And you have to be able to think about things that you don't know, which AI can't do. AI doesn't think about things it doesn't know. It just lies to you, saying it knows exactly what it's talking about. Right? I mean, think of like the strawberry problem, right? How many R's are in strawberry? You know how long that took AI to be able to actually be able to do that? And even now, I don't think it could do it. You know, if you asked it to do that 1,000 times, I bet one of those 1,000 times it would be incorrect. I think it'd be incorrect. At least once. Right? And if you're teaching, 1,000 students, and you tell one of them that strawberry has 5 R's in it, right? Like, that's a problem. So, that's why I don't think AI is, this big thing that everyone thinks it's going to become, because in so many cases, it wouldn't be able to replace an actual human. Because it just doesn't have the skills to teach itself, or it doesn't even have the skills to admit that it doesn't know something. And I don't think they'll ever add that. I mean, that's on the companies to add that, right? That's not like the problem with the AI itself. It's the fact that the companies physically, don't want that to be a thing, because you don't want to you talk to something and have it go, I don't know, because then people think, oh, this thing's shit. But it needs to have that. Like, it's essential. Yeah, there we go. If I'm genuinely learning for asking questions and having AI explain the answers, that's not a bad use case. I think it depends. I think it still depends. I think you can... The problem with asking AI questions to learn things is really kind of what I just said, right? Is that it's confidently incorrect. It could confidently tell you that strawberry has 5 R's, right? So, and you can just trick it into doing other things, right? Because it's just prompts, right? So you could probably gaslight an AI into thinking that strawberry has 15 R's, right? I think that's a problem as well. You couldn't gaslight a human into thinking a strawberry has 15 R's. You just... I'm sorry, but there is no human on Earth of, of, I don't know, some age, I don't know, we'll go... There's no adult on Earth, I think, that you could convince them that the word strawberry has 15 R's. Right, but I bet with AI, with enough, going on and on and on at it, you could convince it that. I think that's kind of a problem. Or at least not really a problem right now, but I think it will become a problem if people if people want to use it for actual things. It's just not going to work. So you think the problem with AI is that it's not deterministic enough? Partially. I think that's definitely a problem with it too. Yeah. For sure. I mean, I totally agree, yet the code that I'm producing seems to be working. Do you think this is something to do with the user's ability to notice the problems and adjust accordingly? Maybe? The thing is, you say your code is working, right? But the question is, has the AI covered everything that the code needs to do, right? Because AIs don't always think of edge cases as well. And it also massively depends on the prompt you give it. Because if you give it a shit prompt, it's going to give you a mediocre response, probably. So it's about like asking yourself, have you... I don't really know how to say this, to be honest. Have you correctly asked it to do everything that you want it to do? Or have you just given it everything you're currently thinking it should do, but have missed things? I mean, I guess you could say the same thing about people, right? You could. Because obviously people miss things, right? I don't know. I mean, it's hard to say. Obviously, I don't think anyone knows what the future of AI is, where it comes into play. I don't think it'll be used as widely as everyone thinks it's going to be used. I don't think there's any world in which that could be the case. I don't think AI is going to replace teachers. I honestly don't think it's going to replace programmers. It's been getting better at programming, for sure. Don't get me wrong. But when it comes to like back-end stuff, it struggles, right? It couldn't write what I'm writing right now. And this isn't... It's not that complex, right? Because it would mess things up. It would miss, I don't know, some niche thing on the JLS specification because it skips things. It determines the tokens that will come next rather than thinking, is that correct? Even if you put it on thinking mode, I'm sure it would miss things. I mean, even the couple times that I've used ChatGPT, right, to write certain classes, right? Let me try and find an example. Let's find an example. Let's see. Okay, for example, yeah, this is a good example. Right, so here, right, it's written this annotation record. But what it's decided to do is it decided to unify single, normal, and marker. Which technically, yes, you could do that. But that's not a good way of doing it, right? There is now no way, it's impossible even, to know what type of annotation this is. You can't know if it's a single, a normal, or a marker, right? You could maybe assume that, like, okay, if it has no values, then it's a marker. But that could be incorrect, right? Because you could do... Oops, not what I meant to do. You could do deprecated, like that. That would not be a marker, right? That would be a... normal, I think? Actually, maybe that would be a marker. But say you had... Okay, say you had one value, right? But it could be like... It could be value is equal my value, right? There's no way to know the difference between that and this, because they're both a single value, but one is a single and one is a normal, right? So obviously AI hasn't thought about that. It hasn't thought, like, this could cause a problem, right? That's why it doesn't really, it's not able to think, and even more so, it can't forward think. It definitely cannot forward think. It can't think in the future and say, you know, it just can't. It just can't do it. At the end of the day, I do think that just relying on AI is a problem for learning. For me, it's ultimately the goal with or without AI. I think AI, ultimately, as like a final take, I think AI is a good tool. It's a tool. It's not a solution. You know, I don't think it should do everything for you. I think it should be used as a tool, and that's it. Right? Same way that an electric screwdriver doesn't screw in the screw for you. You gotta pick it up, move it to the screw, put it over the screw, then press the button, and then hold it for as long as the thing. It doesn't do it for you. It should be used the same as with AI, right? It shouldn't do it for you. It should be used as a tool. It is a good tool, though. It is a good tool. It is. I'm not disputing that. I just think it shouldn't be used for more than a tool. Like you wouldn't want a screwdriver going about just screwing in screws for you randomly, right? Because it thinks, oh, maybe there should be a screw here. Like, you wouldn't want it to do that. Because it doesn't know that, like, maybe in the future, I wouldn't want a screw here because maybe I want to put something else there. I don't know. That my analogy kind of falls apart there, but you get the point, right? Yeah, that would be it would be terrifying, yes. If there was a screwdriver that was just floating about putting screws in random places, that would be absolutely horrifying, but yeah, like, you just don't want it to do everything for you. You want it to be something that you can use as a tool. Anyways, this is all we need in this class. It's a really great analogy. You're welcome. I think it's very interesting. I should make that short. Should I make that short? I've never made a short before. So actually I probably shouldn't make it short because I have no idea what I'm doing. Maybe I'll make that a short. Yes, make it a short. Okay. You can make it a short for me if you want, Alex. Since you have nothing else to do. Short, great. Okay, that's going to be a short coming soon, guys. Is this correct? This isn't correct. What the hell is this? Wait, this doesn't do anything. I meant to do children. No, children. Adult cases. There you go. This is complaining because switch case isn't a thing, but that's fine. We can add that in a second. Yeah. Oh, see, this actually lists like the specific jets that they were part of and stuff. Yeah, I'm gonna want something like that, but I will probably I don't know exactly how I'm going to do that, but I'll probably annotate it with a class, right? I'll probably say something like since is actually a JSON thing anyways, but I would say like since Java, say Java version dot something, you know. That'd be probably a good way to do things. Anyways, accept needs to visit a switch statement, which needs to be the correct switch statement. Nice. Then we have switch rule. That would actually, I agree, be a better name. Hi, sorry, I was at my basketball training. That is all good. Better late than never, right? That's what I like to say. Okay, switch rule. So switch rules are pretty simple, I think. I don't think there's anything really with these. So we need to have a span, as I'm sure you guys guessed it. So span. We have a list of switch labels. Label? Okay. It'd be good if I could type. Right, so that would be the labels. Wait. Yes, because you can have multiple labels, right? So you can do switch. Like a switch on, you know, what can I switch on, guys? Give me something to switch on. I don't know. What enums do I have in this project? I can't think of what enums I have. Okay, let's just switch on a number. Switch on 4, even though that doesn't make sense. Int.bytes. That's not a thing, bro. Oh, unless you mean integer.byte. Oh, no, never mind. It's not going to autocomplete because I'm not in the method. Main. You can do that, right? Can't. Man, we need a freaking project Valhalla. Anyways. Yeah, so you can do like this, but you can also do like case 2, right? So there's a list of different labels that you can have in there. And then you also need to have a body, right? So the body could either be an expression or a block statement. So the best way to represent that is just using a statement, because you can have an expression statement. So that's fine. Let's implement the methods. Return switch rule. This will be a list. No, there needs to be a new array list like that. Add labels. Add body. Return list.copy of. Once again, AI messed up there, guys. It tried to just return children. We don't want to return children. We need to make it immutable, because otherwise that's going to cause problems. AI did not think of that. This is exactly what I'm talking about. Perfectly proves my point. Thank you, Copilot. Next is switch label, I guess. So really, there should just be an interface, right? A switch label. So let's create an interface. And I guess this should extend AST node as well. But let's make this sealed so that we can permit some things. Now, does permits go before or after? Oh, sealed classes must have subclasses. Right, so I can just do permits, no? So I can just do like case label and default label. I think it actually needs to go there. That makes more sense anyways, doesn't it? Case label. Interesting. Is there not Huh. How does this class define if it's a default or not? I don't think it does. Huh. Who knew? Anyways, There we go. So switch label. Then we just have a case label, which is fine. So new class. Let's actually create a new package for this. Switch. Oh, I can't call it switch. What can I call it, guys? I can't call it switch, because switch is obviously a Java keyword, so we can't call it that. What can we call it? I don't know. I could swap out the I with a 1. That would work. But that's stupid. I could call it switches, but that's kind of silly. Or switch. No, that doesn't really make sense. What can I call this? I don't want to call it switch statement because it's already in a package called statements. I genuinely have no idea what to call this. I'm just going to call it switches. Switch. I hate that so much. I hate that so much. I'm going to call it switches. Oh god, that's going to break everything. Don't do that. Let's just rename to switches. And let's not do either of those. Switch label, switch rule, switch statements. Okay. So now we can have a case label. So we can do a new class, record, case label, takes in their span, then it takes in a list of case item, which is the items, and then this implements a switch label. Do we have like a switch? No. Well, we do need that, so we need a case label. I don't know how I don't have that, I'm gonna be honest, guys. Switch. Yeah, so then we need a case label. Okay. And then we need a default label. Switch label? That's not a thing. Is that a thing? No, I don't think so. I think it's lying to me again. See, it was obviously fairly confident that's a thing. Once again, AI, guys. Can't trust it. You actually can't. That's fine. This just needs to import that. Okay, so case item, list.copy of items. That's fine. We haven't created that class yet. Visit case label does need to be a thing though. So let's close some things real quick. Don't need any of these. We'll keep that open for a second. Visit switch rule. So let's visit case label and then visit default label. Okay. So then that's that one. That's expression stuff. We can come back to that at some point. So that's fine for now. Switch rule. Yep, that's fine. We can come back to that one. The only one we need now is a default label, which is just nothing. right? There's nothing going on with default labels. It's just a span implements which label, and then we add our kind, which is default label, no children, business.accept default label, boom, boom. This is going to complain for a second, so let's create our case item, which is a record. I did forget to make that a record. Now, once again, this is going to be an interface, actually, because it's going to have multiple different types. So we will say extends, or yeah, extends is correct, isn't it? And then this is an AST node, and then permits our different types, right? So we have a constant, which would be a constant. We would have a pattern, which is the new stuff, right? And then we have null. So yes, so we have a case constant, a case pattern, and a case null. We'll actually make these subclasses though this time. In fact, we could probably do that with this one as well. Or should we? Yes, let's do that. So let's delete this. Okay, like that. And then case label, we'll do the exact same thing here. So case label, which will go inside of here. Now these don't need to be public. That needs to be that, and that needs to be that. And then we can just go into here and fix that. We have one related problem though, that's just import, so that's perfectly fine. Okay, so then we have our 3 cases we need to have in here. So the constant will just be an expression. The pattern will need to be some kind of like pattern class. We don't really have anything for that right now, do we? Just having a look at the JLS. Okay, so the pattern can either be a type test pattern or it can be a record pattern. So like you have the new record pattern matching stuff. So okay, we'll come back to that one and we'll do these 2 for now. So record, case, constant. Okay, that already needs to be that one. These are going to need to be the same. Okay. This needs to take in a span, and then it needs to take in, what, an expression, I guess? I believe so. Expression, which we don't actually have a class for yet, but we'll come back to that in the future. Expression, which implements case item, and then this needs the children, which is just, you guessed it, the expression. Visit case constant, that is a thing we need to have. Likewise with this, so we need case constant. That's not Java 12 though. Case pattern might be Java 17. And And then case null. That's just been a thing all the time, has it not? When was case null added? Not sure. Not sure. If anyone knows, let me know. I'll have a look at that later, though. Okay, so we want visit case constant, visit case pattern, visit case null. Like that. Okay, then we'll create... we're actually... Sure, we'll keep that for now. Because we're going to create a thing for that. And then case null will just be a span. Right? Nothing special with that one. Doesn't have any children or anything. Now we need to create the pattern. Now, patterns can also have a... there'll be something else there as well. So, Java language specification. I'm looking for switch case pattern matching. Hopefully this comes up. This is a Java language update. I'm trying to have a look to see. I need to find it in the JLS though. I might have just found it. Nope, this is a language update. God damn it. Where's the freaking language specification, man? Okay, I think I found it. Java language specification. It's inside. Yeah, I'll show you guys what I'm looking at actually. Where is it? I just lost it now. No. We're looking for switch statements, guys. Let me know if you see them. Or if I've gone past them, more specifically. Exception. Block statements patterns. Here we go. Switch statements. So let's go into the switch statement for now. Okay, so it switches on expression, which then has a switch block. So a switch block has our switch rules, and then a switch rule has a label. Right, so we're going to switch label, which can be a constant, a null, or a pattern. So, this is what I was looking for. So I thought there was something else. So there's a guard, which is to say when expression. Now, I don't entirely know how guards work, I'm gonna be honest. Does it mention it here anywhere? About guards? A case label is said to be unguarded if it either I has no guard or II2. So yeah, there's the second one. Or it has a guard that is a constant expression with the value true and guarded otherwise. In case label may have an optional when expression known as a guard. Right. Is it going to give me an example of that or no? Here's what I was looking for. So these are guards. I've never used one of these before. So yeah, you basically say, like, case integer I when, and then I is less than or equal to 0. So this case would only run when I is less than or equal to 0, and it's an integer. So it's basically, if you think about it, an improved if statement, right? Because it's basically saying if I is less than or equal to 0, right? Or else, yeah, or else just that, right? So, oh god, it's gonna be kind of complicated. So what I have to be able to do is I have to have a pattern, and then I also need a guard, because the guard isn't within the pattern. So it goes case, and then case pattern, and then inside the case pattern is the guard. So we have here a pattern, and then we have a guard. Now a guard is just an expression, so that's nice and simple. So we can do I don't think guards are used anywhere else, I'm gonna be honest, but regardless, no pun intended, we have a public record guard, which is just an expression. Now we don't have that in here, so we do need a case pattern guard. Case pattern guard. So apparently that's Java 17 as well. That adds up to me. That makes sense for that to be Java 17. But once again, oh god, I'm yawning so much today. I actually don't know why. But yeah, there you go. So that's that. Then we just need here visit pattern guard like that. Okay. So then the only other thing we need is a pattern. Now a pattern is actually quite generic. Guards might not be specific to switch statements actually. I think they are though. I think they are. You know what? I don't even know if our token type allows for when in our Lexa. Let me find... Where is it? I'm looking for the... So this is the Lexa, but I'm looking for the implementations. But where's the Java Lexa? Here it is. Oh, it's in impl. Okay. That makes sense. Okay. Do we have a when keyword? No. We do not. We very much do need that though. So, when keyword. Because yeah, I think I've heard of it like once before, but I've never seen it. And I don't think I've ever even had a use for it, so... It is a thing, though. Anyways, let's go back to the AST. Impl. Wait, this isn't impl, though, is it? Not really. Not really. These are not... I mean, yes, they kind of are, but like not really. So let's just move them out of there. Okay, and then we can get rid of the impl package. Perfect. Okay. So now that in generic, we can just add a pattern class, which is actually an interface. I don't know why I made it that, because there's two types of patterns. Let me... Okay, so... In terms of patterns, we have... as I say, two types. So we have a type test and then we have a record pattern. So a pattern does extend an AST node. That's correct. Let's make this sealed and permits pattern dot type test pattern and pattern dot record pattern. Okay. So we want a record type test pattern. Now a type test pattern is a span, of course, and then it's a type ref. So type ref, or just type is fine. And then it's the name, which is the variable name, or just variable will do. So then we can just have a list of both of those. This is a type test pattern. Let's import, and then record pattern will be that one. So in here, the record pattern is a... Yeah, this is not correct. So the record pattern is first, obviously, a type, but the type here needs to be a class. So it needs to be like, because this just destructures a record, right? So it needs to be a class type. Is it this one? Oh no, it's class or interface type ref. There you go. So this will be the type. Then it has a list of pattern, which is the components, right? And then it has the name, which is like, it's optional, right? So this would be the name, but this is optional. So this needs to be optional of name, because you can have something like, for example, how we would use this, right, is we would say, we'd have our record pattern. So my pattern, sure, whatever, we'll just say this is correct. This is obviously not correct, but we'll say that's correct, right? So the way we would do this is we would have no, this is kind of isn't what I want. But we would have like switch on object, some object, right? And then we would say switch on some object. We would say case type test pattern, but then it would be, we destructure it, so we would say like this. So we have the span, the type, the name, but then we can also give this a name, so we can say that this is like pattern, right? No? Can you not do that? 1 second, I will have a look. Record pattern. So a record pattern is a reference type and a... Oh, you can't do that. I thought you could do that. But sure, we can still destructure it anyway. So we can destructure this to have these different things inside of it. So a component pattern list is a component pattern. Yeah, so at least one component pattern, which is a pattern or a match all pattern. What? 1 second. I'm reading this again. So it's a reference type, which is the type, right? So that's our type test token, like that. And inside of that is a component pattern list, which is a component pattern, so at least one, and then it could be more component patterns. Now, component pattern is a pattern, right? So one of these. So eventually that will go down to a local variable declaration, right? Which would be like one of these. Oh, but I guess I can destructure like span or something, right? So I could say that span is, I don't know what span actually is. It's int pos, end pos, line column. So I can say int pos, int end pos, int line, int column, and as long as I don't name that span, you can do that, right? Because that's record destructuring. But then the thing that confuses me is the other thing is a match all pattern. And I don't know what that is. It just says it's a dash or an underscore. So does that mean it's like this? Or is it like span underscore? Is that what it means? Unnamed patterns and variables and yes, I think that's what it means then. I see. Okay. So yeah, that just has a list of pattern then. But ideally, it has a list of component pattern, which is either a pattern or a match all pattern. But then I guess a match all pattern is really just a... Wait, actually, I think it's like this. Yeah, it's just that. So... Okay, I can make another record then, right? So I can do a record match all pattern. Add that to the permit list. And then in here I can do a wait, do I have the other ones in here? So like record pattern, where's record pattern? Yeah, so then I can have a match all pattern, which is gonna be I don't even know what version that's from. Is it 23, I think? Check version, there we go. We're going to have a lot of to-dos in there. But yeah, that'll be a match all pattern. And then that means that we can have a visit match all pattern. Like that. Okay, this becomes pattern, which is the correct pattern. And then expression, that's fine. Because we need to come back and do that. Okay. That's all good. So I think we just need to do this real quick. So let's have a list of AST node children equal to a new array list. Let's add the type, let's add the components, and then if the name's present, we add the name and return a copy of the list. Perfect. Let's get rid of this as well. Don't want to leave that around. Okay, so that's our patterns. So then in here, we have default label, case label, right? And this takes in case item. Case item refers to the case pattern, which refers to the pattern class. Yeah, okay. Okay. This is getting quite quite deep in terms of the complexity of things, but I think that's basically everything with the switch statements. I think what's the one after that? Where are we? We are. Yeah, so that's all the switch statements. That's switch rules, that's the case labels, the case patterns, etc. Okay, so the next is a while statement, which is super simple, actually. While statements are as simple as it goes, really, in terms of like what they represent, right? Because it's just a condition and a body. That's it. So we have a span, then we have an expression, which is the condition, and then we have a... I think the body's optional. I'm actually going to look at the Java, the specification again real quick. While statement. While statement, here we go. So while statement, so we have is a while and then a statement. But it could be a while expression or and then followed by a statement no short if. Statement without trailing substatement, labeled statement no short if. I don't understand. Oh, it's to do with like nested if statements. So when you have like, you can have like if statement, right? Oh no, not if statement. If, yeah, if condition, right? If condition, blah blah is equal null, whatever. And then inside of this, you could have if other condition is equal null, right? You could say south high or whatever. But then if I wrote an else here, it's basically saying like, where should this else belong, right? Should the else belong to this if statement or should it belong to this if statement, right? Because you have to think that the parser doesn't know about whitespace, so it doesn't know that it's only indented once, so it could be there, right? So it's just about like figuring out which one is correct. Now I think that's not important for us right now, but I think we just want a statement. But we'll see. Because for do whiles, that's not going to be the case. So that implements statement. Then we can just implement the methods, which is a while statement. This is just a condition and then body, and then that's visit while statement. Like that. I guess we can have a look at what the other ones do. While statements. Classes, all places. Let's go this one. So this just has an expression and a body, and this just has the body being a statement. So yeah, it's nothing special. The JLS says it could be a statement no short if, but I assume that's a different type of while loop or something. I think so, yeah. I think that's the case. Okay, so the next one is a do while, which is just a while statement, but with the statement before the expression. That's it. So I'm actually just going to copy this, do while, and then put the statement before the expression, put the body before the condition, like that, and visit a do while statement, change this to a do while statement. That's it. That's nice and simple. And when parsing it, to be honest, this is very simple to do as well. You're just checking if there's a do keyword before a statement. If there is, it's a do while. So yeah, that one's nice and shrimple. Do just need to fix this, of course. Okay, then we have a basic for statement. Now, once again, for statements, pretty simple. They're a little bit more complicated. At least the basic one is, because it contains a few things. So we have obviously our span, right? And then we have an initializer. So that's just a statement, to be honest. I don't know why Copilot's trying to create a class for that, because it's just a statement. So an optional of a statement, which is the init statement. Okay, then we have a optional of expression, which is the condition. And then finally, we have a list of expression, which is the updates. So this would be like, so when we have a for loop, right? We have a for I loop. So for int I is equal 0, right? So we have here, this is the, how do I do this? This is the initializer, which I'm just going to call init, but we can actually see what's going on here. Then we have the condition. That's condition. And then finally, these here are the updates, right? So you can actually do multiple things here. So you can do like, I don't know exactly how you do it. You can do that, right? If I do I is less than 50, like that. Is it with commas? Is it like I times equals 5 or something? Yeah, so it's with commas. So that's just then a list of expressions. I've actually never seen this. I'll be honest. I've never seen anyone do multiple updates. But I mean, there's no reason why you can't, right? It's just a very random thing to do, I guess. But anyways, that's it. That's literally all a for statement is. Oh, and obviously the body. Oh my god. The most important part, which is it's actually technically not a block statement, right? It doesn't have to be a block. We'll just do a statement body. And this just implements statement. And then, yeah, everything you'd expect. So visit basic for statements. That's fine. So that adds the init statement, then it adds the condition, then it adds the updates, then it adds the body. Okay. And that's it. That is literally the entire for statement class. Then we have enhanced for statement, which is a little bit more complicated, unfortunately. So as usual, we got our span, Then we have modifiers. So a list of modifier, which is the modifiers, because you could have like a final var or something. I think you can even have annotations, right? Yes, you can. So then we can have a list of annotation, which is the annotations. Then we have the type, so that'll be a type ref type. Then we have a boolean is var. Then we have a boolean is var arg, or var args. Then we have the name, which I'll import real quick. And then we have the expression, which is the iteration. What do I call this? The iterable expression? Or really is no, iteration expression. And then we have a statement, which is the body. Like that. Okay. And this just implements statement, and then everything else is, you know, the same as it always is, right? Enhanced for statements, which I probably didn't call that. What did I call it? Enhanced. Isn't that what I just had? Oh. Oh, I was lazy. Statement. Oops. Enhance for statement. I didn't remember being lazy, but here we are. List of AST node children equal a new array list. Modifiers, annotations, type, name, iteration, expression, body, return it. Nice. Then this is just visit enhance for statements, which is that. Okay. What's this? Okay, that's just because of the expression. That's fine. Yeah, this is pretty simple because you could have like a for, you know, final at not null integer, or it could be a var, or it could be. Wait, how would you have var args? 1 second. Is this correct? Enhance for statement. Okay. So it has a for and then a local variable declaration. Yeah, but it needs to have no initializer, right? So we could just use a local variable declaration, which we already have. But the problem is, it's technically, well, it kind of is, I guess. Should we do that? I think we'll do that, actually. So we'll have a local variable declaration statement, which is the local variable declaration. But effectively, this cannot have an initializer. Right? So then we just do children to add that, which saves our code a little bit of mess. Not a huge amount, to be honest, but a little bit of mess. Obviously, they're still going to complain because of the expression, but that's fine. Don't care about that. God, there's still so much to do. I think we're just over halfway, guys. Actually, no, because we've done a lot of these. So actually, we don't have a huge amount to do. We have the expressions, and then we have literals, prose, of course. I don't know really why prose is with these ones. I feel like prose should not be there. I guess it is slightly different, but... Well, no, I would actually just put it here. But yeah, it should really be there. I'm going to put it there with the other ones. There you go. So yeah, we have the rest of the statements, we have the expressions, and then we have the literals. But honestly, guys, I think I'm going to end the stream here. Just because I need to put dinner on before I go out later. So, but you're still doing these visit method. Yes, it is kind of crazy wide, but there are so many to do, and we have to make classes for every single one of them. So, it is what it is, and it'll make the parsing easier when we actually get to that part, because we won't have to create tens of classes whilst we're parsing it. It will just be a bunch of if statements, for loops, that kind of thing. It won't be anything crazy. But anyways, yeah, I'm going to end the stream here. I will probably stream again on Saturday, I think, is what I'm planning right now. But yeah, I will see you all then. Goodbye.